In chapter 4.6, we're going to talk about rational numbers and what they mean. But first, let's talk about what you should know by the end of the class period. Hopefully by the end of this, you will be able to identify and graph rational numbers and be able to evaluate fractions containing variables. Now, what is a rational number? First, let's go into what a whole number is. Now, before we get into the confusing rational numbers, it goes in order by difficulty. So let's talk about whole numbers first. Whole numbers are any positive number including 0. So 0, 1, 2, and so on. Keep going up and up and up. Those are called whole numbers. Now if I were to take this 0 out, these are not whole numbers anymore. These are natural numbers. So I know that they don't have natural numbers written in here, but I want you to know that the first level is actually natural numbers, and those are the numbers that you counted when you were a little kid. You would say 1, 2, 3, 4. You wouldn't start at 0. Those are natural numbers. So all the numbers that are greater or equal to 1. Whole numbers are the same as natural numbers, but instead of starting at 1, you would start at 0. The next one that comes after that is integers. So we talked about going from 1, 2, 3, 4, and so on to 0, 1, 2, 3, 4, and so on. And now when we add in the integers, that's actually when we start adding in the negative numbers. Now notice, I have seen no fractions so far, so in whole numbers, natural numbers, and integers, those are all whole numbers. Now some of you may say, well, Mr. Sand, there's a fraction right there, and there's a fraction right there. Well, 3 divided by 3 is 1. And 12 divided by 6 is 2. So really there are no fractions. So now let's go into what a rational number is. Whole numbers, natural numbers, and integers are all rational numbers. But rational numbers are also fractions. So let's take a look here. 6/7, that's a fraction. So I would say that's a rational number. Is it an integer? No, because it's not a negative or positive whole number. Is it a natural number? No, because when we count, we go 1, 2, 3, 4, 5, 6, and so on. We don't go 6/7, 7/7. And it's not a natural number because it's not a whole number. So let's go to this one, -3/4. Well, it's still a fraction, so that's perfect. Does it matter if it's negative? Nope, because rational numbers are integers, which means that they can be negative. Now what can we see right here? I see a repeating sign. That's what that little line means. That means that 4 goes on forever. So that means that when I see a decimal, if it's repeating, it's considered a rational number. So remember that. If it's repeating, it's a rational number. We have a mixed number with a fraction, same as these ones. It's still a rational number. We have a decimal that ends. Okay? That's called a terminating decimal. That means it ends and it's done. So if you want to think about the Terminator, get in the chopper. Well, if you're going to think about that, the Terminator, it ends. He's this big robot who ends a lot of things and, I don't know, blows stuff up. And those things unfortunately aren't around anymore because he blew them all up, like buildings and all that stuff. And I'm just babbling on, but you know what I mean. And this is also just a fraction too, but an improper fraction. So basically what we learned today is a rational number. What we've learned so far, we're not done, is a rational number can be a repeating decimal. I'll just put des. Terminating decimal, which means it has to end. It doesn't go on forever. And it can be written as a fraction. So let's go look at some examples here. Write 2 lists of fractions equivalent to 2/3. So basically what they're asking you is 2/3. Write me some other rational numbers that are equivalent to 2/3. And this is what we talked about in the last chapter too. So 2/3, I would say, let's times the top and the bottom by 2. I just picked that randomly. So let's just times the top and the bottom by 2. That means I would get 4/6. Let's say I want to times the top and the bottom by 10. That means I would have 20/30. Now what if I want to make things more difficult on myself and kind of impress Mr. Sam with my math skills? What about -2/3? Well, you guys should know that a negative divided by a negative is a positive. And up here, a positive divided by a positive is a positive. So if I were to divide these or divide these, I would get the same answer. So this is considered equivalent. The same thing with this, and the same thing with this. Because my fraction was equivalent. Now, or my fractions that I just wrote are equivalent. And now some of you would say, well, why do I need to make two lists? Well, what if I want to make one with just positive numbers? So like I had here, 4, 6, 20 over 30, 200 over 300, and let's times the top and the bottom by 3, so I get 6 over 9, and let's times the top and the bottom by 5, and I can get 10 over 15. So there's one list. Now, is it in order? No. But basically, I'm just giving you examples of what I could do to make a list. Now, my other list could be the same thing, except instead of using all positive numbers, I'll use negatives, because we know that a negative divided by a negative is a positive. So I could write all the same answers, but the top and the bottom are both going to be negative, because a negative divided by a negative is a positive. So make sure that you understand that. So on your test at the end of the chapter, and I ask you to write some list to show equivalent fractions, some of you might just take the easy way out and kind of do this stuff, where I just times the top and the bottom by 3. We already did that. What I want you to understand is that a negative divided by a negative is a positive, so these are actually also equivalent. Now we need to graph these on number lines, and this is what people struggle with the most in this chapter, because we don't know where the 0 is and what they're in between. So I'm going to first look at this first problem here. Of course, I would start with the first problem. I wouldn't start at C or B, but anyways, negative 3/4. Now I know that it's a negative number, so I know the 0 is going to be on the right side, because we count like this: 0, 1, 2, 3, and so on. So I know that negative 1 would be right here. So I know that it's a negative, and this is between negative 1 and 1. So I know that it's going to be somewhere between negative 1 and 0. Now, I should know that the middle right here is negative 1/2. Now, do you have to be exact and say negative 3/4 is exactly right here? No, you don't have to. But what if I'm going to erase this middle, and what if I broke this fraction into 4 equal pieces, because that's what 3/4 means. Break it up into 4 pieces. So let's say here's 1, 2, 3. So here's 1, 2, 3, 4 equal spots. So this would be negative 1/4. This would be negative 2/4. And this would be negative 3/4. So my best answer would be to put a dot here, and there's my graph. Next one. 0.5, well, it's a positive number, so I know 0's here. And I know 0.5 is between 0 and 1. So we're going to put not a 0 right there, a 1. And we should all know this one. Or 0.5 is the same thing as saying 1/2. So if I break this number line into halves, so 2 equal pieces, just like this, then 0.5 would be right there. I put my dot there, and I'm good to go. The next one should also be easy. Whoops. The next one should also be easy, because they're just asking you, do you know where 0 is on a number line? So 0 we could put there, but what I would want you to do then is go like this: 1, 2, 3, negative 1, negative 2, negative 3. So that shows me that you know where negative should be and where positive should be. The last one, I see that it's 1/3. I see that it's not bigger than 1, but it is positive, so I know it's going to be between 0 and 1. Now, the bottom, the denominator says to break it up into 3 equal pieces, so I'll try my best. Here's 1, 2, and 3 equal pieces, and I only want 1/3, so here's 0, or 0/3. Here's 1/3. Here's 2/3, and then actually, I know I wrote 1 here, but that's the same thing as 3/3. So I'm just going to put my dot over 1/3, and that is how you graph rational numbers on number lines. No shading, like inequalities, just make sure you put a dot there. Last one, we got a story problem here. A fast sports car can accelerate from a stop to 90 feet per second in 5 seconds. So I'm going to highlight this number, 90 feet per second, in 5 seconds. Now, what is its acceleration in feet per second, feet over square, or s squared, because it's second per second. That's not a typo. This is true. When you take physics, you'll notice this. Use the formula A equals F minus I over T. Now, do you have to memorize this for your test? No, because I will give it to you if you need to use it. But the nice thing here is that they give A is the acceleration, F is the final speed, I is the initial speed, and T is the time. So, what do we know? We know that a fast sports car can accelerate from a stop to 90 feet in 5 seconds. So I know that I have the time. The time is, I'm going to take this out, the T out, and I'm going to put 5 seconds in for time. The next one, do I know my final speed? My final speed that I reach is 90 feet per second. So I'm going to take out this F, and I'm going to put 90. Do I know my initial speed? Well, Mr. Sand, I only see two numbers here, and you've already used both of them. How fast are you going when the car is stopped? The answer to that is 0 miles per hour, so you put 0. Now, if you read the question over, it says, what is its acceleration? Well, we're solving for A, so we know that we did it correctly. So we should know from PEMDAS we have to do what's on top first. So 90 minus 0 is 90. So we're going to do 90 divided by 5. And if I do 90 divided by 5, we can do it the long way. How many times does 5 go into 90? Once. Bring down the 0. 5 goes into 40 18 times. So the acceleration is 18, but 18 what? They said, what is the acceleration in feet per second, or feet over second squared? So I'm just going to write feet over second squared. That looks funny, but they were nice enough to give us the units. So all we have to do is put the units on our answer. So all we did was plug it in, plug it in. Oh, that was really good, right? Anyway, plug it in and get our answer, and then make sure that we label. So 18 feet per second is our answer. Now, the main key components about this was knowing that a rational number can be written as a fraction, or it can be a repeating decimal, or it can be a terminating decimal. So next lesson we're going to go over irrational numbers, which are the opposite of rational numbers, and we'll be able to decide which one's rational and which one is irrational.